Yeah, you can go to the next slide, please.
Next,
Sorry.
I'm sorry.
Yeah. Yeah, because I just put together a little bit of an agenda on the topics that I'm going to discuss today. Of course, first I want to start with an introduction on what bunkering actually is, the different types of fuel, the complexity of bunkering, and I cut that into two pieces: the stakeholders, processes, and the procedures. Of course, regulations, IMO 2020, but I think we need to look at IMO 2020 as only the starting point. There is a little bit more to it. The technical aspects of bunkering. And then, of course, I also want to give a bit of a sneak preview into the future of bunkering because there are quite a lot of changes ahead of us. And of course, there is more than enough room to answer any questions that you might have. Yeah, and you can go to the next slide.
Sorry.
Yeah.
This one.
That one, yeah. And then I would like to start with a question and maybe raise your hand if you know the answer. Does anybody know where the name bunkering comes from? I quite often also do the bunker experience course, and there are always a lot of people that are already in bunkering, but it's not that often that people know the answer to that question or know where the name comes from. So does anybody know where it comes from? I guess not. No. Oh yeah, I see a hand. Kirill?
Claudia, this page, yes, right?
Yeah, that page.
And
But I see that
yes,
Kirill raised his hand.
some small communication is wrong now. And could you tell again, this page is okay, yes?
Yeah.
Or we step another one?
No, this is good. This is the good
Yeah, okay.
page. Yeah. Yeah, and I was just curious if anybody knew where the name bunkering comes from. But bunkering comes from in the good old days when ships were still sailing on coal, where they stored the coal, that was called the bunker. Well, ships don't sail on coal anymore, but we still use the. Oh, Kirill wants to say something, Igor.
Yeah, hello.
Yeah. Yes, we can hear
Yeah,
you.
that's what I would like to say. That as far as I know, it was information from the ICS book that the bunkering goes from the when ships sailed on the coal, the special tanks where these coal are stored was called like bunkering. And generally in the shipping, we have a lot of uh, fast words like sailing from the ports. Um, yeah, okay, I forgot some other words. So the in the general, yeah, the word bunkering comes from the later the sorry.
Yep, correct, indeed. The word bunkering comes from the place where they stored the coal. And it's quite interesting that a lot of people in our industry who are working with bunkering every day don't know this. So it's only one word that we use, but it also illustrates the history of bunkering. It's something which is, yeah, already there from long time ago, and a lot of the words we still use. Bunkering, of course, it is the transfer of fuel from a vessel's cargo tank to another vessel's fuel tank. And that sounds obvious, but we have to remember or understand that bunkering is not a ship-to-ship transfer. So when we transfer fuel or cargo from a cargo tank to a cargo tank, It's not called bunkering, but it's called ship-to-ship transfer. And it's also subject to different rules and regulations. We had some cases in the past where we were doing tests, for example, on taking something off the receiving vessel and loading it into a bunker barge. Of course, when you call it debunkering, oh, no, the presentation is gone. I'll just continue until we have the presentation back. So when we call it debunkering, it's basically classified as a waste transfer. And if it's not waste, we have to call it ship to ship. So it's really important to understand bunkering is only when it goes from a cargo tank to a fuel tank. You can go to the next slide if you want. Yeah. And as I just mentioned, the word bunkering already comes from the good old days when ships were burning coal. But it's basically not that long ago that ships used or started to move from coal to fuel oil. It's in the First World War that we started because they could store more fuel than coal. And even in 1940, there was as much oil as coal being used. So it's not that long ago that we made the move to oil. And for quite a long time, we have been sailing on oil and gasoline, so all of the derivatives. But now the industry is in a transition phase. And yeah, as much as we want to decarbonize for the next decades, there will still be a lot of oil being burned. But it's not only oil anymore. So we get this mix of fuels, which I will also touch upon later when we look at the future of bunkering. You can go to the next slide. So when we look at the different type of fuel, I've made a very simple image of a distillation column. Ships or shipping companies have been, for a long time, been burning the waste product of a refinery. Of course, kerosene, the gasoline that we use in the cars, paraffin for chemical substances, they all are higher quality products. And ship engines are designed in such a way that they can burn, as they say, the bottom of the barrel. So the very cheap fuel oil. And that also made our industry very spoiled because everything else that we do is considered to be more expensive. And that's not because those fuels are that expensive. It's just that the current fuel was just so cheap because it was a waste product. So we have the conventional conventional fuels, which all come from the crude, HFO, heavy fuel oil, MGO, marine gas oil, and all of those substances. We also have the gaseous fuels, of course, like LNG and LPG. They also come from the same source. And then nowadays we have a mix, as said before, with also the low and zero carbon fuels like the biodiesels. And quite often you see people talking about a B24 or a B30. And basically that means that within the blend there is 24% bio. So B24 is 24% biodiesel and the rest is fossil diesel. So the higher the B, the more bio component. All of those biodiesels can have different feedstocks. Most of them are FAME-based, fatty acid methyl ester. You don't need to remember, but it's a feedstock for the biodiesels. And we have seen in the early days when people started to use these quite a lot of compatibility issues. And that is why now in the latest standards on fuel, so the ISO 8217, there is also a standard for biofuels. So ship owners that burn these biofuels now also have a quality standard that they can refer to prevent issues with the engines or in the separators. Then, of course, another part of the low and zero carbon fuels that we're currently looking into is the LNG pathway. Fossil LNG for the moment, but eventually more people will blend in bio LNG and synthetic LNG. So little by little decarbonizing the fuel that they use. And then, of course, we have the more exotic ones like methanol, ammonia, and hydrogen. And coming back to what I just mentioned, from most of the ships just burning oil or MGO, we are now getting into this mix of all of those different fuels, which all have their own specifications and all have their own safety perspectives. So that has a huge impact on the bunkering itself, but also on all of the roles that everybody plays in the bunkering industry. You can go to the next slide. Yeah, and it's not only the different fuels that make bunkering so special. As said, it's the transfer of fuel from a cargo tank to a fuel tank. But fuel for most ship owners is around 70% of the operational cost. So that makes that there is a lot of focus from all the stakeholders in that supply chain on the fuel. But all of those stakeholders also have their different KPIs. The fuel buyer, of course, he wants to have the cheapest fuel. The chief engineer on the vessel wants to have the highest quality because he doesn't want to have any issues. So everybody has a different aspect and a different angle on fuel, but they all have something to say about it. Well, on top of that, there are operational challenges, and I will go into that in a bit more detail later on. But bunkering sounds easy, but it's not. Operating a good bunker or performing a good bunker requires skills, and the whole supply chain does deliver quite a lot of challenges for people. And to make it even more complex, we have rules and regulations in place, not only the environmental regulations, but also where can you bunker, what do you have to comply with? And yeah, as we all know, geopolitics play a huge role. Shipping is one of the very few global industries. So ships can be today in Rotterdam and next week somewhere else, and there are all different rules and regulations that they have to follow. And when we have sanctions coming into play, it makes it very complex. So the planning of bunkering becomes more and more a dedicated skill. And although bunkering, for me and many other people in the industry, is the most important thing that they look into, for a ship owner or somebody who transports the containers, for an example, it's just hassle because when they call a port, they are there to offload or unload containers. So bunkering has to be done when they are also doing their cargo operations. That's what we call SIMOPS, simultaneous operations. And it's not only the loading or discharging of containers, which is supposed to be SIMOPS, but also cruise vessels. They want to bunker their vessel when the passengers are getting on and off the cruise vessel. So you have to apply to certain rules to make sure that that is safe. And last but not least, the bunker barge itself. And on the picture there you can see a typical inland bunker barge which you see in Rotterdam. And this is currently the biggest inland bunker barge in the world. It's the Vorstenbos. And yeah, in the part of the Netherlands where I come from, people don't have a lot of knowledge about the maritime industry. So when they think about inland barges, they always think about a very small vessel with a family living on it. But these bunker vessels are very sophisticated and highly technical, developed devices because they have to ensure that everything happens safe and fast so that the container vessel, for example, can quickly leave the port again because every hour that they stay longer costs a lot of money. You can go to the next slide, sorry. But it's not only that makes bunkering so special. As said before, ships sail around the world. They fuel the global economy. They fuel the global trade. I have a daughter, she's 21, and I have to be honest that she's pretty spoiled. So she has her own car and she has her own phone, and every 2 years a new phone. And of course, people of that age have a certain view on what we do in the maritime industry. So I have sometimes very nice discussions with her about decarbonization and money going around in the global trade. But it's due to these global ships sailing around the world that we can have fresh fruit in the winter. So we also have to understand that we live the way we live because of ships trading around the world. And of course, they need to be fueled. Oil dynamics, we all know when there is something happening somewhere, the first thing that happens is sanctioning the oil countries and deliveries. And without fuel, you can't run your ships. And that has a huge impact on everything we do in our global economy. And one thing that I didn't put on the slide, which is also part of the global trade, what we have seen a couple of years ago when there was a vessel stuck in one of the canals, we don't have trade. So we are depending on the global trade, and we are depending on, for example, the Suez Canal and the Panama Canal to keep that economy going. And that's where we need the ships for, and they need the fuel. The problem with the global economy and the global trade is also that the local compliance is not always the same as on a global level. And I will come back to that later, because especially last week at IMO made a huge impact on everything we do in our industry. But it's also the availability and quality of fuels. In the days when heavy fuel oil was the only fuel that ship owners bought, it was pretty easy to get it everywhere in a proper quality and sufficient amounts. But that is now changing. If you're running a vessel, for example, on methanol, you cannot get that in every port. So you really have to plan in a different way. And also we have seen a couple of years ago, there was a case in the US where there was a lot of contamination in heavy fuel oil. So a lot of ships, they had blackouts, and it took a long time before they could really find out where the issue was coming from. So availability and quality of fuels is very important, but also the traceability and the transparency. Because if there is a wrong batch of fuel somewhere, it's not just one ship that gets that fuel. There are many of them, and they sail out across the world again, so the issue can spread. But as said before, also the complexity of stakeholders, and I'm going to zoom in on that now on the next slide, please. Yeah. So I've tried to find an illustration to show the complexity of stakeholders. And it's quite difficult because it's very depending on every situation. But if we just take an example of one ship, one vessel, we have the owner of the vessel. We have the fuel buyer. That doesn't always have to be the owner. It can be the ship operator, the ship manager, or the owner. And then quite often, especially when we talk about large volumes, they use an intermediary, either a fuel broker or a trader, that helps them with procuring the fuel. And then, of course, we move to the supply side, the fuel supplier. Oh, yeah, there's a question I see, but we'll get back to that for the next slide. So we have the fuel supplier. Sometimes they own a barge or they own the trucks, but sometimes they also charter a logistics provider. So there are also different stakeholders involved. And then, of course, we have the surveyors, especially with so much money and fuel going around. People want to make sure that they get the right quantity, the right quality, and that they get exactly what they paid for. As said before, they don't want to spend longer in port than needed. So there is an agent to make sure that the bunker vessel is there on time, that everything goes smooth, and that everybody knows from each other when to deliver the bunker. But we also have the more indirect stakeholders, the crew of the vessel using the fuel. Especially with the new fuels, they need to be trained in a different way, because handling heavy fuel oil is something different than handling methanol or ammonia or LNG. And something which becomes more and more relevant nowadays is also the cargo owner. And I will get back to the regulatory side later. But also the cargo owner nowadays has something to say about the fuel. And then we have the regulatory bodies, compliance, water police. So this list of stakeholders is quite a long list. And that also makes bunkering so dynamic and so special. You can go to the next slide here. And when I was discussing in EBIA that I was trying to map all the different stakeholders, they mentioned that they tried to do the same. So this was their version. But they also realized that it's so complex that it's almost impossible to put it on one slide. So I just wanted to show you this, that even for people in our industry, even for the International Bunker Industry Association, it's quite a challenge to properly map all of the stakeholders involved in the bunkering supply chain. You can go to the next slide. And then, I just want to quickly touch upon this. Bunkering is done by barges in most of the ports, especially with the big volumes, you have dedicated bunker barges. But there are different ways of contracts that those barges operate. So what you see most often is the time charter base. So a fuel supplier pays a fixed day rate for the barge, and they just do the deliveries on behalf of them. Some of the physical suppliers have their own barges. So then they do the fuel, but also operate the barges. Then there is a different business model because they want to do as many operations as possible, because that brings in more money. You also have the spot charters. So based on a dedicated job or voyage or a delivery, they can just charter a barge and then let it go. And sometimes you also see the charter based on the price per ton. So there is another incentive for the operator to do it in an efficient and safe way. And I think there was a question. I'm not sure if that's a question related to this or a question for later.
What you want? If you want now, okay, go ahead.
Yeah, good.
Yes, Michael, Kirill's iPhone asking question for future. Claudia, could you read it?
Yeah, I'm just checking in the
Uh-huh.
chat.
Okay.
Yeah. Could you please clear RMG, RMA? Yeah, that's a different it's a different grade of the fuel. So they are basically sort of the same, but they have a slightly different specifications on density, viscosity, and yeah, how do you call it? The flame point. Yeah. So they're just slightly different grades. Checking the COQ sent to me by trader or physical supplier on what items I have to pay attention, accept CP terms with owners and avoid. Oh yeah, very important is what I just mentioned in regards with the biofuels. Nowadays, the ISO 8217 2024 is the latest specification. But quite often people, fuel buyers, they just ask for the ISO 8217 and they don't specify which version. And there might be big differences in the different version. An ISO 8217 2020, for example, has complete different specifications as the ISO 8217 2024. So it's always very important to check if the right specifications was ordered and delivered. So that's one of the things that I would definitely advise you. What worst and best ports for bunkering? I mean, where there are a lot of claims with bunkers and where it's almost absent. Yeah, it's a very good question. In the past, Singapore was one of the worst ports, and that was not always on quality, but mostly on quantity claims. That's also the reason why they started to implement mass flow meters, and I will get back to the mass flow meters later. And the big case on quality claims that I mentioned before in the US, that was in Houston, where it was traceable that there was something wrong in a certain production facility. So quality and quantity claims, unfortunately, you have them all over the world. Sometimes it's easy to, yeah, find where it comes from. Sometimes it's not, but it's a global challenge, so to say. But on quantity specifically, Singapore has now almost no issues anymore because they use the mass flow meters. Some other ports as well. If the owners have time frame for claim to bunker, yes.
Hello.
Yeah, I can hear you.
Yeah, hello. I just would like to speak a bit more regarding the question two. I'm asking I'm acting at the time charter, yeah, and I have to supply the bunker, the fuel to the vessel. Of course, first of all, I'm read CP terms, which ISO standard owners want. But for instance, when I'm trading the bunkers, I'm asking a certificate of quality, the typical certificate, just for my reference, usual note from the trader. And I would like to understand, for instance, if the CP clause says not much regulations for the supplied bunkers. And I checking the certificate of quality comparing to the ISO standard. For what points I should pay most attention? For instance, why I'm asking this question, I have now a bunker claim. Sorry. What? Yeah. For now, I have a bunker claim from the off-spec claim, from the owners, saying that MGO too high a seed number. And when I start learning about this, go deeper in the details, I found that generally this acid number could not damage vessel very high. The main point, this fuel should be used like as soon as possible in order not to start a rust in the tanks and not to damage with the rust to the main engine. And the reason of this question, maybe you can advise all for exact what points we should pay attention when we buy fuels. Because, for instance, as far as I know, the viscosity, for instance, it's like it's shown in the ISO standard, but it's not pay a very valuable information. And what I mean, the general viscosity, it's like normal, but maybe you can advise to what points I should pay attention in other specifications.
Well, when you look at viscosity, when you look at density, those are things that don't really harm the equipment on board. So the things that could have a potential impact on the equipment on board indeed are the chemical substances. So indeed, like acidity, chemical substances that are in the fuel. So that is something which I would definitely pay attention to, because it can also be that not directly when you start using it, the impact becomes visible. It can also be on the longer term. So you might have compatibility issues with fuel which is still in the tanks. So one of the most critical quality aspects are the chemical substances. So that would be definitely my recommendation, to keep an eye on those. If they are off spec, I would always raise a letter of protest. Because, and that's also your next question, you can only raise a letter of protest when you sign off for the bunker delivery note. So if there are doubts about the quality, and you don't even know yet if it's going to be harmful or not, always raise a letter of protest, because then at least you can investigate afterwards if there is a potential danger or quality claim or not. But if you don't raise a letter of protest directly after the transfer, you basically you're not entitled anymore to raise a claim, unless it's that obvious. But in general, you only have that time slot straight after the delivery.
Yeah, got it. Yeah, thank you.
Yeah. Yeah, and it's a very interesting one also what you mentioned on sample staking, that a lot of barges don't want to be taking it off for the barge. The marble sample has to be done on a ship manifold. So that's the legal sample that have to be taken. And of course, in addition to that, there is quite often another sample just to, yeah, as a backup in case there is an issue or if the buyer wants to check it. A lot of the barge operators don't like it to be taken on the barge because they fear that they don't have control what happens on the ship. So for example, if they take the sample on the barge, it might not be representative for what happens on the ship that burns the fuel. So that is why there's quite a lot of hesitation. Normally, or in most of the cases, it's a contractual agreement where to take the sample on top of the marble sample, which has to be at the ship manifold. Michal says, which region of the world has the most various offer of different types of fuel oil? Yeah, well, Rotterdam is one of the ports in the world where you can find most of the different types of fuel. And that's purely because Rotterdam is a port where we have a lot of the big oil majors, a lot of the chemical firms, they have their terminal storage there. So there is a lot of supply. But also Singapore has a lot of supply. Houston is a main bunkering hub. So there are some around the world, but Rotterdam is one of the big ones. Cat finds, yeah, indeed. There's also a really good one. Good, Alexandra. Yeah. Yeah, so I think those were the questions for now. So maybe we can go back to the slides.
Yes.
Yeah, and I think we can go to the next one. Yeah. Yeah, and of course, I've put this slide in because the way that bunkers get procured is not only depending on where the vessel is sailing and how the contract structure works, but it's also depending on the type of ship. A lot of the tankers, they work on the spot market. So today they don't know where they will be tomorrow. So for a bulk carrier or a dry cargo or a tanker, which is on the spot market, it's very difficult to plan ahead when it comes to bunkers. A container ship with a fixed route, it's pretty easy. Most of them, they just sail between, yeah, say Rotterdam and Singapore. So you know, or China, so you know exactly where to buy your bunkers. So the type of vessel also has an impact on how you buy your bunkers and where to get your bunkers. And then, of course, yeah, we have inland vessels. They are not even subject to IMO, so they follow the local rules. So they can get their bunkers from a truck somewhere on the shore side. So there is a very different way of approaching the bunkers depending on the type of ship. And yeah, you will all get also the presentation of this. And if you click the link of ships, then you get all of the different information. You can go to the next slide. And then when we look at buying bunkers, there are basically four key decisions that you have to consider when buying bunkers. Of course, what to buy, so the type of fuel and the quality, as we just discussed in the questions, but also where to buy. As said, it's a global industry, but you need to be compliant. You have different environmental compliance areas, so you have to make sure, okay, where am I sailing? So do I need to have a specific fuel for that area? So you need to know upfront. How much to buy? Quantity measurements. When I started 15 years ago, my first job in the maritime industry was selling bunker flow meters. And the whole reason that those were introduced into the bunker industry was that nobody really knew exactly how much they got, because there is a lack of transparency when it comes to quantity measurements and bunkering. And when to buy? Of course, depending on the type of vessel, where you go, how the prices fluctuate in the market, you can either go for the spot market or hedge your prices or hedge your fuel procurement and do it direct or via brokers. So there are different ways on when to buy and how to optimize your the price that you pay for your bunkers. But all of that together, all comes together in the bunker procurement plan. And we see that more and more often that buying bunkers becomes a dedicated job and really becomes a skilled part of our industry because of all of the complexity around us. You can go to the next one. But when we look at that price of fuel, it's not only the fuel. The price of fuel comes from a lot of different aspects. It's the fuel itself, but also the logistics. Take Rotterdam again as an example, where the sailing distance between the terminals and the receiving vessel is fairly short. You don't have a lot of add-on for the logistics. But when you have dedicated barges for specific fuels, for example, those logistics costs can be quite high. But also compliance has an impact on the price. A cleaner fuel has to go through different steps in the production process to be compliant and does also have a price impact. We also see that when we just talked about the ISO specifications, when there is a new ISO specification, because it requires additional testing, those fuels might be a bit more expensive than from the previous specification. So all of those aspects have an impact on the price of fuel. So it's not just the fuel itself, but it's also all the different angles around it. And then, of course, what if the fuel that you bought is not correct? What if there is something wrong? And then you can go to the next slide. Because then we come into the topic that we just discussed. That is where you have to raise a letter of protest. And there are many reasons why contracting parties submit a note of protest. Most common, of course, is when the quantity of the fuel is not good. So, for example, if you buy 1,000 tons, but the barge only gives you 900, then you miss 100. So that's a reason to raise a letter of protest. And that can only be done at the moment there. A note of protest or a letter of protest is a formal record of an intention to pursue a further investigation. So as I just explained to Kirill, only if you raise that letter of protest, it gives you the tools to do further investigation, either on the quality or on the quantity. Barge will never sign an LOP. True, they will do as much as they can to prevent that, because it takes them time to do it and they want to go to the next delivery. It's basically a sign that the owner or the buyer or the customer doesn't trust them. So they don't like that. And I've seen cases where also the chief engineer on the buying side was very hesitant to raise this letter of protest because he really got into a fight with the barge operator. But if you have doubts about either the quantity or the quality, let them shout on the barge, but raise that letter of protest, because that's the only paper that you have to just enable further investigation. And of course, they don't like it. Nobody likes that the other side doesn't trust them. But it's part of the industry and part of what we should do when there is a reasonable doubt that something is not good. You can go to the next one. And then, of course, we also have a lot of processes and procedures in place when it comes to bunkering. Some of them are port related. For example, bunkering in Singapore has to be done according to the Singapore Standard 648. That tells you something about the way of working, the level of knowledge and competence for surveyors, for barge operators. So it basically describes the whole process of bunkering that you have to follow in Singapore. Then we have ISCOT, and I don't really know what it stands for, but those are the bunkering standards and procedures in ARA, which is Antwerp, Rotterdam, and Amsterdam. So there you have to follow those kind of standards and procedures. And then when it comes to the alternative fuel bunkerings, we suddenly also get the JPOB's, the Joint Plan of Bunker Operations, which is a mandatory preparation plan and list of documentation that have to be done and completed before you can start bunkering those fuels. On top of that, we have mass flow meter standards. At Singapore, they're already mandatory. Rotterdam and Antwerp are following from the 1st of January. Some other ports are following as well, some slightly different. So there are a lot of local processes and procedures that you have to follow when you are bunkering in those areas. And then, of course, in Rotterdam, there's also a notification tool called Portbase. It used to be time to bunker. So barge operators have to submit the data that now we're going to connect, now we start delivering, now we stop delivering, just to make sure that there is traceability of what happens. There are also some changes to sampling requirements. In MEPC, we just spoke about the sample point at the bunker manifold. ADN also has a change where it's not allowed anymore to open the tank hatches on the barge. So a lot of the barges are now equipped with different sampling equipment. So there is a lot happening in the industry at the moment, and everybody gets a little bit lost in all of the different rules and regulations. Let me just check which questions there was. Oops, cold trader. Yeah, exactly. And vessel costs money, op should call trader, master issue LOP at the same moment when the LOP received, op should send a message. And it is a lengthy process to raise this letter of protest. And I'm not saying that all of the barge operators are not trustworthy, but you have many of them that use this as an excuse. If you know that your receiving customer or the receiving vessel is in a time squeeze and they cannot raise a letter of protest, then that is your opportunity to do a shortage of delivery or do something else which is not okay. So they use this in their advantage. And indeed, quite often, if there is only a 10 metric ton difference or a 20 metric ton difference, it gets settled somewhere halfway, everybody happy, and they continue. And if it's acceptable for both parties, perfectly fine. But the problem is that as long as these kind of things get settled in the background, the industry as a whole doesn't get the overview of where the issues are. And then a wrong barge operator or a wrong fuel supplier can continue to do what they do. So it's something that it's an issue in bunkering, and there is a lack of trust because of these kind of things. And also because of the complexity of stakeholders that we discussed before, the one that sees the 15 metric ton shortage upon the delivery is not the one that ordered the fuel and is not the one that pays for the fuel. So bringing in all of those stakeholders for just a couple of metric tons is quite often not worth it. But yeah, if we really want to make our industry more transparent and more honest, we should do it. Easy for me to say, sitting here, but yeah, it's an interesting discussion. And why some suppliers implement barging cost and others no? Well, that has to do with the different type of contracts, as I just mentioned. So, for example, if you are a supplier, a physical supplier, and you have your own barges, the barging costs are already in the fuel price. If you have to hire or charter a different barge to do it, they can put it on top of it. So it depends a little bit on the type of contract that the supplier has with the barge operator. And some of them just put it into one big bucket and they just say this is the price. And some split it up and do it as a add-on. So it depends on the type of barging contract they have. Yeah, you can go to the next slide. So yeah, besides all of the local processes and procedures, of course, we also have the regulatory landscape. It all started with the Paris Agreement, where as a world, as a society, we have to limit global warming. And that also reflects on shipping, because we are more and more being forced to use less fossil fuels and reduce emissions. When we look at IMO 2020, that was specifically implemented to limit the amount of sulfur in the fuel oil. On top of that, there were already ECA zones which even have a more strict limit of 0.1%. So in general, in 2020, the whole industry went from 3.5% maximum to 0.5. But on top of that, we had the ECA zones, environmental compliance areas, or the SECA zones, sulfur environmental compliance areas, where there was even a more strict limit. Since 2020, those areas have been expanded and more areas have become ECA zones. And I can still remember, I think it was in 2019, I was at a bunker conference where many of the fuel suppliers and fuel producers were complaining about IMO 2020 because it would have a huge impact on their refinery process and it would make everything more expensive and there would never be enough for everybody. And all of the ship owners were really concerned that this would indeed lead to lack of availability of fuels. But it became 2020 and there were no issues. Of course, some minor issues, but they will always be there and they were already there. So IMO 2020 was for our industry the first big step into environmental compliance and regulations. But it was just the beginning. So now you can go to the next slide. And as part of IMO 2020, since then, we have had so many rules being implemented for shipping. And I can still remember that when I joined the industry, a lot of people said to me, why are you going into the maritime industry? It's so boring and nothing happens. Well, I think if there is one industry where a lot happens, it is shipping. And if we just look at the last couple of years when it comes to regulations, it was IMO 2020, so the sulfur reduction. Then we had the EEXI, SEMP, CII rating in 2023. And I will explain all of those abbreviations later. And then we had, of course, the CII score, EU ETS, EEDI was implemented. EU ETS was even further discussed or is still discussed. So all of those rules and regulations all focus on reduction of fuel and reduction of emissions. And then you can go to the next slide. And I will come back to your question, Kirill, after the regulatory element. So all of those regulations focus on CO2 reduction and on fuel reduction because emissions come from fuel burned. So the less fuel we burn, the less we emit. But also the type of fuel has an impact because every fuel has a specific CO2 emission factor. So when we take the EEDI as an example, the Energy Efficiency Design Index, that's an indicator for every new built vessel that tells you something about how environmentally friendly that ship is. So it's the power, so the type of engines, the output, the fuel consumption, and it's all theoretical because it's for a new built ship, the CO2 emission factor of the fuel that's going to be burned, but also the capacity and the ship speed. So this is why you see that a lot of the container vessels some years ago, they got bigger and bigger. So that will mean, indeed, that you improve your EEDI. So all of those regulations, and then you can go to the next slide. All of those regulations focus on the fuel being used and amount and type of fuel. So on the design of the ship, it's the EEDI, the Energy Efficiency Design Index. On an existing ship, you can calculate the EEXI. So if you do a retrofit and you put a new engine in it or something else, you can calculate the EEXI. Operational, we have the carbon intensity indicator. So suddenly also the number of miles and the number of cargo being transported and used has an impact. And then of course there is the Ship Energy Efficiency Management Plan, SAME, which every vessel operator has to perform to show that this is what we do to reduce fuel consumption and measure also the impact of the actions that they take. And as I said before, in the complexity of stakeholders, we also have the cargo owners having something to say about the fuel. That's about the Scope 3 emissions. Because large corporates in Europe, nowadays, they have to report their CO2 emissions. And then I think then you can go to the next slide. Yeah. So I will come back to the Scope 3 emissions after this slide, because I wanted to highlight this first. We spoke about the local regulations, ECA zones, SECA zones. We also have the Norwegian fjords being emission-free, FuelEU, Renewable Energy Directive, all sort of local regulations focusing on emission reduction. On the global side, there was a plan to come with the IMO net zero framework. Last week, unfortunately, it was decided in IMO to postpone the implementation with 1 year. And I'm still hopeful that in a year from now, we will have the IMO net zero framework. And that will basically put a price tag on the type of fuel that you use. So it doesn't prohibit you of burning a fossil fuel, but it makes it really expensive to continue to do that. So the IMO net zero framework would be the first industry-wide global regulatory framework to drive decarbonization and emission reduction. Unfortunately, it's postponed, but it doesn't mean that it's going to go away. And on top of that, coming back to the Scope 3 emissions, especially in Europe, we have the Corporate Sustainability Reporting Directive, where owners, cargo owners, are pushing to lower the emissions of their whole supply chain. And then you can go to the next slide. So as a cargo owner, say you are a producer of goods, you have Scope 1 emissions. That's the emissions of producing your goods. Scope 2 is indirect, so that's the emissions of the purchased electricity, for example, or the fuel that you use to produce your goods. And you have the Scope 3 emissions, and that's where the maritime industry falls under. So transporting containers with sneakers means that Nike, as producer of the sneakers, needs to report the emissions that the ship emit from transporting their sneakers. So they have something to say about the type of fuel burned as well. So they are pushing for cleaner fuels. They're not always willing to pay for it, but suddenly that 2.8% of emissions coming from shipping has a ripple effect into the industry, because we are suddenly not only our own Scope 1 emissions, but also somebody else's Scope 2 emissions, 3 emissions, sorry. So the push for emission reduction, even despite the fact that the IMO net zero framework is now put on pause, will continue, because the whole society and cargo owners are getting more and more pushing on that. And let me just check the questions before we move to the next chapter. Could you please advise if China already SECA zone, and if no, now the vessels still use IFO at ports? China is not a SECA zone as far as I know. I think the latest zone that was implemented was the Mediterranean. And as part of the implementation of the IMO net zero framework, there was also the North Atlantic region, but that's now also postponed. And if they still use IFO at ports, yeah, true. But I also see in parts where there is a SECA zone that they still use fuels which should not be used. But yeah, if they use a scrubber, they can do it so far. But yeah, it's not widely implemented yet. As you know, it will be the following discussion: alternative fuels and bunkering infrastructure, from fuel choices to supply chains at World Maritime Forum in Copenhagen. Please, what decisions you think will be made? Yeah, what I hope that will be discussed is that despite the setback with the IMO, inland, correct, but not in the sea side. What I hope that will be decided is that we continue the efforts that already put into place. But I'm a little bit afraid that, the ones that want to do it, they will continue. But the ones that don't want to do it see this as a good reason to not do it. And indeed, the postponing was the result of ship owners resisting our current US administration or something else. I think it's a combination. It's definitely the current US administration that has been very vocal about the sanctions if people would vote in favor for it. I also believe that a lot of people who were in favor of it also realized that there were still a lot of gaps that need to be solved before we can implement it, and that maybe made it easier to follow the no votes. So I think it was a combination. I've spoken to a lot of people who were there last week, and everybody says that it was very chaotic. It was very political. Many member states had huge legal support, armies with them to make sure that they could find the gaps to, what potentially could go against or in favor. So I don't think there was one specific item that led to this discussion. But yeah, let's hope that we still continue to decarbonize, because we are already late. So we have to continue what we do. And then we'll dive into the bunkering itself. So we go a bit more into the technical aspects. Yeah, you can go to the next slide. So when we look at the bunkering basics, there are different ways of bunkering, but they are all connected by the same dynamics. Of course, we have ship to ship, barge to ship. We have truck to ship for the smaller amounts or specific fuels. Shore to ship, which you quite often see with tankers. And then we have something which is specifically for the ARA region, which is double banking. And that means that you can have two bunker barges next to each other. And you can see that on the right picture. There is a limitation, so you cannot have endless number of barges next to each other. It's also depending on the width of the waterway. But of course, as vessels are being pushed more and more to leave the port as soon as possible, this is one of the key drivers that helps in bunkering in Rotterdam or in Antwerp, because it can speed up the process. Then there are always a lot of discussions on the flow rate which is acceptable. Barge pumps can pump really high flow rates, but quite often, as the crew on the receiving vessel is busy with so many other tasks, they prefer to have slightly lower flow rate, just to make sure that if something goes wrong, you don't have the huge spills. So all of these things have to be discussed up front. Do we do SIMOPS? What is the expected flow rate? What is the temperature? Because that tells you something about the pressure needed, the communication lines. So all of those elements need to be discussed before you can start doing the bunkering. But also, again, those local stakeholders, the locations. When we look at LNG as an example, most of the ports have their dedicated bunker map. So you have designated locations where you can bunker LNG, methanol, in the future ammonia. So you have to check what the locations are and if it's possible to do it at the terminal or not. But also the politics around it. Yeah, coming back to the letter of protest, there are also quite a lot of politics, and maybe politics is not the right word, but games are being played. If you know that your customer is forced and under time pressure, and you want to deliver short, then that is the right way to do it. So yeah, there are also politics, and then of course late arriving of the barges, all those kind of things are elements in bunkering which are not the best parts, and there are definitely elements that we are not proud of, but they happen. You can go to the next slide. But also the process itself, as I said in the beginning, bunkering is a complex process. It's supply chain related, so we have the stakeholder complexity, volume to mass conversions. I just had a call earlier today with one of the big suppliers, and now that they see more and more barges being equipped with mass flow meters, they start to doubt the measurements of the terminal. But the terminal, they measure in volume because they have the huge land tanks and they don't have the mass flow meters. And now the barge is measuring in mass. So you're not comparing apples with apples. So all of those different measurements, those conversions, have an impact on the accuracy and the transparency. Temperature compensations. A land tank is pretty easy to keep in a stable temperature, Then it goes to the barge, it goes through cold lines. From the barge, it goes to the receiving vessel, below deck, where the temperature again is different. That also leads to measurement uncertainties, but also, yeah, as we said at the beginning, concerns about quality and quantity. And in general, it's huge amounts going around. So all of these supply chain related challenges make bunkering difficult. But it's also the operational difference or operational challenge. When comparing two measurements with each other, they are seldom exactly the same. If I'm driving my car and I have the speedometer of my car and I have the speed that my navigation system indicates, they are never the same because they use different types of measurements. So which one do you trust? And when we look at bunkering, we have the barge measurements, we have the flow meter, we have the tank measurements on the receiving side. All of those are different, so that leads to discussions. Then, of course, the process itself. You can't do a bunkering without air. We all love to have a bunkering without air because air has an impact on the volume, but you just can't do without it. And then, of course, the different qualities, specifications. With mass flow meters, there was always a fear that flow would go back to the meter and you would count it or you would not count it. Pumps that are configured in the wrong way or operated in the wrong way, introducing air. And of course, as it's bunkering and people want to leave that port as fast as possible, you will not, or you don't want to be in a situation where you're depending on repairs, service engineers, parts that are not available if something breaks down. So it's a highly challenging process on the supply chain side, but also on the operational side. And then you can go to the next slide. So how does that bunker process work from an operational side? It sounds easy. And I have a picture here on the left side of a traditional bunker barge with pumps. And I've seen cases where a barge was designed to carry heavy fuel oil, and then suddenly they changed, so they started working for a different customer, and they went to biofuels, say a B24 or a B30. So the stem sizes were smaller, the viscosity was different, but the pumps were still designed for heavy fuel oil. So suddenly the pumps were cavitating and they were introducing air into the process. So all of those measurements were incorrect. And there were a lot of discussions between the barge and the receiving side. Eventually, people found out that it had to do with the pumps, so they changed the pumps and everything was good. But also using mass flow meters requires a different way of bunkering. It requires specific actions that you have to take before you start to bunker. Conventional barge operators are not used to that, and they don't like it. So there are a lot of differences in the way of operating that indicate or that determine if it's a good bunker or not. But also the temperature, the viscosity, and alternative fuels. On the right side is a picture of an LNG bunker vessel, which was being loaded at an FSRU. There the whole process is completely different again as with conventional fuels. The amount of paperwork, the documentation, the safety elements. So those operations take a lot of time and dedicated skills. So bunkering is definitely something which is not easy. And it might seem daily business because it happens so many times around the world, but it does require specific skills. You can go to the next slide. And of course, I've mentioned mass flow meters a couple of times, but in many parts of the world, they are not standard yet. So a lot of the measurements are being done on manual sounding. Most people that do manual sounding know how to do it, but it can also go wrong. So you can have a tape error leading to a wrong measurement, and then eventually leading to a letter of protest and discussions with the barge. Temperature sensors that are not hanging in the cargo but above, and then with the calculation from level and temperature and density to volume and to mass, you get an error and you can't really trace where the error comes from. But also stratification. It doesn't happen that often with conventional fuels, but it is something that we have seen a lot in the early days of biofuels. So depending on where the density is measured in your tank, you can get a different density. And again, calculating volume with density to mass can lead to an error or an uncertainty or an inaccuracy. So manual sounding can be done very accurate, but because of all of those conversion steps and the potential errors, it can also be very wrong. You never know. So you always have to make sure that you follow the right process and the right measurements. A barge which has a trim or list doesn't use the correction, gives you a wrong number, and then suddenly you do raise this letter of protest, and then they find something somewhere in a different tank. So all of those things have to be checked when there is a sincere doubt about the quantity. But there is a solution for that. Then you can go to the next slide. And that's a direct mass measurement. And people often ask me, why should I measure mass? Well, if we look at Paris, there is a standard kilogram, because a kilogram is a kilogram, independent what the temperature is. But there is not one standard liter, because if we have a liter or a ton of fuel oil and the temperature changes, the volume increases. So with a volumetric measurement and the temperature increases and you don't do the right calculation, you think that you got more, that you think you got 1027 liters, but basically you only got 1000 because the volume expanded. But air doesn't have a mass. And yeah, I think it still happens in some parts around the world where we have cappuccino effect. And that means that they on purpose inject air into the fuel to boost the volume. Then of course the tank measurements on the receiving side think that there are full tanks. And then after a couple of days sailing, all of the air has disappeared from the fuel and the volume has dropped. And there were issues that vessels definitely got a blackout in the middle of the ocean because they didn't got the amount of fuel that they thought that they got. So that was also the reason why people moved to pushing for mass flow meters for bunkering. And then you can go to the next slide. Because mass flow meters, as the word already said, they measure direct mass. And I've just put in a screenshot here. A mass flow meter, a Coriolis meter, and you have different suppliers that deliver them. They measure direct mass flow, but they also measure if there is air in the fluid, and they measure density. So you eliminate all of those conversions. So you have your direct mass measurement, but you also have sort of a first indicator of the quality because you measure the density. And if there is too much air, the density goes down. If there is, for example, seawater in the fuel or chemicals, the density will go up. So it gives you a sort of a first indicator about the quality of the bunker and the quality of the fuel. So that led to the development of mass flow meters for bunkering. But then when we look at mass flow meters for bunkering, or in general every measurement, and you can go to the next slide, please. It is a custody transfer measurement, and that means that it's a sales transaction where the ownership of the property changes from one to the other. And it also has specific requirements for the measurement devices that are used. Those sounding tapes have to be calibrated, but mass flow meters also have to be compliant with MID, Measurement Instrument Directive. And we have those applications as well on the land side, gas pipelines, the gasoline for your car. But there is one main difference between all of those measurements and bunkering, and that's air. Because if you fill up your car, there is this little glass bulb at the gas station to check that there is no air, because that's a condition to do an accurate measurement. But in bunkering, you can't really do without air because of the process conditions. It also at the gas station shows you that the whole measurement is being calibrated, is being checked on an annual basis. So you have to do that for measurements in bunkering as well. So using mass flow meters for bunkering have to comply with all of those regulations. And because the process conditions are so challenging, you cannot do it just a meter. So you have a full system around it, which quite often is very expensive. But that's the only way to do an accurate measurement. And then we can go to the next slide. And when Singapore started to make the use of mass flow meters mandatory, they also realized that it's one thing to have the hardware and to have an MID compliant measurement system, but we need more to make sure that people follow the right procedures, that they know how to operate that measurement system, that they know how to operate the pumps, that there is no excessive air. We need an industry standard. And that was ISO 221, sorry, I see a typo there, 22192. So it goes beyond MIT. So it's an industry guidance and it includes the whole system, so the hardware, but also the procedures and the documentation. So when you have an ISO compliant barge, that means that the whole system is certified. All of the flanges, all of the lines are sealed. So you guarantee that everything is delivered, goes through the flow meter, so you get the most accurate possible measurement. And it's also accredited by a third party, so an independent body that checks if everything is done correctly. And with that, the industry tries to have a standard which is global and provides the transparency and the trust. Because, yeah, using your words again, Kirill, barge operators don't like letters of protest, and it's a lengthy process and it takes a lot of time. So we need to make sure that we build that trust again and that we have an accurate measurement for bunkers. Yeah, and mass flow meters with the ISO 22192 standard provide that. So that's a change that the bunkering industry is currently undergoing. There is a lot of resistance, mostly because people don't really know what the impact will be on their operations and how it works. But it also shows us now that we start to get insight into the measurements throughout the whole supply chain, because it's only the barge having these meters. So we see that the fuel tanks on the receiving side are not calibrated, and they are quite often not very accurate. We also see that the terminal measurements might have a difference. So it creates a next level of transparency, but it also raises a lot of questions, which the industry is currently very engaged with. So that's interesting times. And then you can go to the next slide. But using those mass flow meters is the first step to truly go to a transparent industry. And the next step is digitalization. When I try to explain to people how the bunkering industry works and that they still use pen and paper and manual pieces of paper that go back and forward between the vessel and the barge, it's out of date. In our daily life, we do everything digital. There is an app on your phone for everything, but in bunkering, everything still happens in the old-fashioned way. So step by step, we are moving into a more digital way of working. Since April this year, Singapore made the use of EBDN mandatory. And EBDN is just the first level of digitalization. It's just a digital bunker delivery note with a traceability, and that's the first step. But we also see, especially when it comes to the new fuels, certificate of compliance. And all of those feedstocks have to be certified, and you have to be able to show that document trail to the regulators to show that you are really using a green fuel. And if we use all of those papers in real paperwork, it gets really messy and very, very lengthy processes. So digitalization of the bunker process, of the measurements, but also of the paperwork is the next step for our industry to move to a future-proof industry. Makes life easier, builds trust, but is also a solution for lack of resources. Everybody is struggling with finding people that want to work in our industry. So if we can make the processes more efficient and more digitalized, it will also help on that side. You can go to the next slide. And it's just a matter of time before those digital documents and digitalization on the bunkering will also have but we'll also find our way into the whole procurement side. There are already tools available, and this is an illustration of StormGeo, where procurement teams can do the whole bunker planning based on data coming from everywhere. So that really helps with doing an optimized and efficient bunker procurement process, making sure that you have the compliant fuels, because you can see what your trading route is. Are you coming into any ECA zones? Do you need specific fuels? So EBDN is really the low-hanging fruit, is the first step, but eventually this is where we want to go to, because that will really build a future-proof and robust industry. You can go to the next slide. Yeah, and talking about a robust, future-proof industry, what is the future of bunkering? Well, first of all, of course, it's the fuels discussion. And yeah, we spoke about the IMO framework. But if we try to put ourselves in the shoes of a ship owner and we're going to build a new build vessel, then what is the fuel of choice? Methane, LNG, methanol, ammonia, hydrogen. They all require significant investments, different vessels, different equipment. So it's not a decision which is made very easily. Of course, the people that made the choice for LNG are now complaining because it's not sure if LNG is still a future-proof choice. So it's a lot of discussion and very difficult to choose the fuel of the future because vessels have a long lifetime and you need to make a choice now which will last for 20, 25 years, which is beyond 2050 when we are supposed to be net zero. And then, of course, there are tools. Tools is maybe not the right word, but there are also solutions that are maybe immature, very costly, not 100% proven yet to be beneficial. Okay, wind-assisted propulsion seems to be very lucrative because you can really save fuel and it also has a positive impact on your compliance calculations. But fuel cells for seagoing vessels, it might be a bit too immature. Nuclear, I'm really happy to see that the first discussions on nuclear are now on the table, and maybe not as a direct source of propulsion on the vessel. But if we can use nuclear to produce all of those clean fuels, then at least the availability issue is not an issue anymore. So those kind of discussions are currently ongoing. But yeah, most of the ship owners nowadays, they just go for the easy solution, which is the biofuels. It's a drop-in fuel, specifications are in place, it's a limited price adder to the regular fuels, and it gives them that first step of compliance until all of those other fuels and solutions are being further developed in the background. You can go to the next slide. But yeah, how will those different fuels impact the way we work in the industry? Well, first of all, of course, it will impact the users. The availability of fuel, the planning of trading routes will be more complex. So that's where those digital tools also come into play. Spot market versus long-term contracts. Yes, MGO is still fairly easy to buy on a spot market. But as said, methanol, there is no spot market. So if ship owners go for a different fuel, they really have to look into long-term contracts and secure their supply. Hedging, take LNG. LNG is very subject to the geopolitics around us. So prices can go up and down and yeah, can change overnight. So if you can hedge your prices for those kind of fuels, it has a positive impact. But everything we do will be more expensive because we are spoiled by burning the bottom of the barrel. So everything we do will have an impact. And yeah, people are afraid to make a wrong choice, which I fully understand. But the only wrong choice is not doing anything because eventually we have to go. And the closer we get to the deadline, the more difficult it will be to make a choice. So it will impact the users, but it will also impact the suppliers. They will also face the spot market versus long-term contracts. But the flexibility of bunker barges will also be less widely because you cannot use a traditional oil barge for example, carrying a B30 or a B35, because then you need to have a chemical barge. And LNG and methanol and ammonia eventually require completely different type of barges, which are also way more costly and thus have a higher day rate. But also the size will be different. When Maersk announced that they were going to build those methanol container vessels, the amount of methanol that they would need would require really big barges, which were not there yet. Luckily, they realized that the amount of methanol that they need per bunkering is slightly less, so they can do with a mid-sized barge. But all of those elements have to be considered before making a choice, and that is why the way of working will change and the way of collaboration will change. So you can go to the next slide. And then last but not least, when we have all of these fuels, it will also impact the operations, the bunker operations. Different licensing schemes in the ports, compatibility between bunker vessels and receiving vessels. All of those fuels require different training and competence, not only on the barge side, but also on the receiving side, but also the people in the back office. Because it requires a different way of working and you need to know what the impact is on your job. Planning. When I was, the picture that I showed of this LNG bunker vessel, I spent a couple of days sailing on her. And before every loading or discharging, they had to go through a 5-hour pre-bunker assessment. If all of the vessels around the world will go for different fuels, then we have to realize that planning will become an issue, and we need to do a different way of planning. So it tells you something about the potential impact also on the whole industry. Documentation, certificate of compliance, as we discussed before, but also pooling and banking. So within a fleet, you can have one vessel which is over-compliant and use that over-compliance to, on paper, make your other vessels compliant as well. That requires a lot of documentation and certifications. So that will impact the whole operations as well, because somebody needs to own that whole paperwork trail. Public opinion. I always get frustrated when people talk negative about our industry. But we can't really blame them because shipping only comes in the news when there is something negative. And we don't really show all of the good things we're doing and how people are depending on the global fleet and how we transport their goods. So there is also a task for our industry to work on the public opinion and be a bit more advocates for our industry. And time constraints. Those different fuels, they have different flow rates, they require additional checks. So yes, there where a barge could do 10 bunkerings a day, then suddenly it can only do 5 a day. So it will impact the whole supply chain. So bunkering is a complex part of the industry. It's dynamic. It's sometimes a bit, mysterious, but it will get more and more complex towards the future. Luckily, we have tools in place like the digital solutions, like different measurement devices, global standards and frameworks to make sure that we do as much as we can to make it efficient and to make it safe and to make it easy. But bunkering will always be dynamic, and maybe that's also why I love it so much. You can go to the next slide. Because that was in a nutshell what I wanted to tell about bunkering. I can talk for a full day about bunkering, but I think then it might be a bit too much information. So I do want to leave some time for questions from the group. And thank you for your attention, of course.
Claudia, thank you very much. And any question, please?
Thank you, Christina.
If no question, Christina? Julia Malышka. Hold on a second. Yes, Julia, please.
Hi.
Hi.
First of all, thank you for interesting topic indeed, broad. It was a pleasure to hear you, so thank you. And by the way, I've been doing logistics and shipping for decades, and I have no clue about where the word bunker came from. So thank you. Yeah.
I also didn't know, so
Okay, so my question very well simple. If you can share maybe any fraudulent scheme in bunkering, maybe, of course, without names and figures, but just overall.
well, in IBIA we did a survey back in 2022 together with BIMCO, and the outcome of that survey was that on average, depending on the world area, there could be between 2 to 4% on shortages on average. So if you translate that to the amount of fuel being bunkered around the world, it's a lot of money. And the interesting thing is now that when we look into mass flow meters, those measurement systems, they have an accuracy of 0.5%. So you will never get a completely spot on measurement, but we can improve from that 2 to 4% to 0.5%. But of course, those barge operators, that fuel suppliers that used, on purpose shore deliveries as a way of extra income, they are very much against this because they can't really do that anymore. So it's, I think time will tell how this will impact the industry and if we get to a truly transparent and trustworthy industry. But yeah, it is time for a change, and we really have to make sure that we eliminate those fraudulent players.
Thank you. Yes, it's from 2% to almost 0%. It's impressive indeed.
Yeah.
Considering, especially, you're right, the amount.
Yeah, true. But there is currently a new survey. EBI launched a new survey to see what has changed since 2022. And I think the deadline for filling in that survey is the 1st of November. So hopefully before the end of the year, we'll get more relevant data to see if the industry is really improving.
Thank you.
Next one, please.
Claudia and all the greenhouse, many thanks. It's really interesting lecture. I just got the question, is it workable, like I can buy, for example, 10,000 tons of bunker for today for, let's say, $100 and take it during 1 year, regardless if the bunker price will go up or down? Is it workable still on the bunkering market?
With the current dynamics, I don't think any supplier would be willing to sign a contract like that. I know that there are certain types of contracts where you secure the amount today at the price of today, but you can get it as a future delivery. I'm not sure what the time frames are and to what extent suppliers accept that, but you have those kind of contracts, yeah. But mostly you only see that when the market is not so good or when they expect that the prices will go in a different direction.
Thank you.
Thank you. Next one, please.
Claudia, good day. I would like to thank you for your lecture. We've heard a lot of really fascinating and useful information about bunkering, but I would like to ask you, could you tell us something about debunkering? How is the process carried out, and in which cases is it done?
Yeah. Debunkering is also something which in some ports is not allowed. And if I take Rotterdam as an example, debunkering is not allowed because when you debunker, it has to be classified as waste. So for example, if you get a fuel on board which your engines can still burn, then people prefer to not debunker it and just use it. Otherwise, it will cost them a lot of money. Some ports, they do allow debunkering, and then the supplier will take it back because they can use it in another blend again. So it depends a little bit on the type of port, if it's allowed or not. And anyway, if you do it as a vessel owner, it's quite expensive. It takes time. And yeah, I would suggest only do it when you have the type of fuel on board which is just not usable in your engines. So people try to prevent it as much as possible. And then depending on the port where you are, it is allowed or not. And when it's not allowed, then yeah, you have to keep it on board.
Okay, thank you.
Christina.
Yes, hi again. One more time, I want to thank you for this lecture. It was very interesting. My business is far away from bunkering. Now I want to say, unfortunately, it's far away from bunkering because it's really amazing, interesting. One thing that I want to ask about risks. So you tell us that there are a lot of ways to supply bunker inside the vessel, but does it matter? It's outside of port limits or inside of port limits regarding risks?
Yeah, definitely. You do see in port and outside port bunkerings all around the world. And depending on the sea state, you can get a stable connection and it's safe. But of course, when you do it offshore, the connection between the bunker barge and the receiving vessel is always determining if it's safe or not. And we had, when I was working for the previous company that I worked for, they did bunkerings in Oman, Salalah, and that was in port. So you would think that was safe, but the specific conditions there were that there were a lot of swell. So the vessel was always being, yeah, there was a lot of tension on the mooring lines. So it was even in port a very risky operation where everybody had to be really attention to make sure that it all happened safe. So it doesn't always have to be outside the port that it's more risky, but it has to do with how safe can you connect the barge to the receiving vessel. And we see people now talking about ammonia because nobody wants to have ammonia in the port, because if you get an ammonia release, you will smell it very far away. So they say, okay, maybe we need to do ammonia bunkering offshore or at least outside the port limits. But even then, when you get the connection with the barge and the receiving vessel, the issue there again is that you might get a hose failure or disconnection. So even for those fuels, it would be more safe to do it in a calm sea state. But basically, you are, in most of the areas around the world, you are allowed to do it in port and outside port as long as you can guarantee that safe connection.
Thank you very much for your answer.
Yep, yep. And I think we have some questions in the chat as well.
Yes.
Let me see. Yeah. The LOP. Could you please clarify once again if I understood correctly? Bunkering LOP is a formal document, but at the same time it's necessary and only first step for going into further investigation. No LOP, no chance for claim. Yeah, correct. That is basically how the rule is. I have to admit that I don't know if you have not raised a letter of protest and then suddenly you see that something happens with the fuel and you can very clearly state that it's the supplier's side. If you don't have enough room for a claim, I guess if it's that obvious, you can still claim, but it will make the process way more complex if you don't have this letter of protest. So it's basically always the first step. And yes, Ole, you can contact me, absolutely. On the last slide, you see my contact details, so please feel free to send me a message if you have questions. Do you consider these days as the most challenging in bunkering since the beginning of the industry? Well, if I listen to the people that have been in the industry for maybe even longer than I'm alive, it has always been challenging, but the challenges have been different. Of course, going from coal to oil was a challenge, but it was a technical challenge which was pretty easy to solve. And IMO 2020 was a challenge, but it was a challenge that was solved by the fuel suppliers because they changed their production process and we suddenly had these low sulfur fuels. But where we are now is a challenge which requires something from all stakeholders. So it's not a simple solution. So yes, maybe this is the most challenging time in bunkering since the beginning. But yeah, we don't know what the future will bring, so it might be even more challenging. Bunker derivative contracts for long duration fuel supply. Yeah, and how can digitalization tools such as the EBDN contribute to enhancing traceability and legal accountability across the supply chain? Well, the good thing is that when we look at these digital paperwork and digital tools, they track every step from the production till the use of the fuel. And everything is completely documented in a digital supply chain or digital paper trail. So there is no way for people to manipulate papers or to make typos as something simple, which also happens. So that traceability makes it easier. And also, especially with the biofuels, even the producers have to be certified and submit all of those certification documents into this paper trail. So you can really go back to the source, and that will help the traceability and the accountability. The next conventional fuel. Oh, I love that question. I'm afraid that the days of one fuel are gone. So I think we'll get a mix of fuels anyway, and then maybe the most conventional fuel, the way I see it, will still be bunker oil, heavy fuel oil, but then, yeah, or very low sulfur fuel oil, but then with a scrubber or different kind of after treatments. And then the second would be LNG, I think, because that is something which we still have a lot around the world. And yes, it's still fossil, but it's better than what we used to do before. So yeah, sometimes we have to look at the next best option instead of trying to make something perfect, because yeah, it will never be perfect. So, but yeah, I like that question. The next conventional fuel. I think those were all the questions in the chat, right? Oh no, we have one more. Oh, thank you. Yeah. Thank you, everybody.
So we have a time limit, and also if any question, please go ahead. If no, we can finish. Thank you very much, Claudia. Nice to see you, and very interesting lecture. And hope that we will cooperate together in the future. And oh, sorry, I closed my video. And yes, and hope that we'll step in the future together. And nice to see you again in the next hour. How to say, we'll invite you again if you want. Okay.
Definitely. And thank you everybody also for the interesting questions. It's always nice when there is a lot of interaction and questions. You will all get the presentation, so you have my contact details. And yeah, don't hesitate. Just reach out if there are any questions or if you want to share some insights. I'm more than happy to take that afterwards. So thank you all for your time.
Thank you. And всем до свидания. See you next time. Bye-bye.
Thank you. Bye.